So, good afternoon, everyone. Thank you very much for your time. And today I'm going to be talking about AI in preventative and predictive maintenance. But to kind of kick it all off, we'll be talking about what we call the world of motion, just to kind of set the scene. So, with Festo, when we talk about the world of motion, it's about how we're making things move. So, we've got what we're known for, the core pneumatic automation. We've got electric automation, and then we've got what we call the lifelong learning, and that's about training and developing people. But overarching all of this is what we call digitalization or AI, which is dropping into every single product that we're creating. The best way to really put this into context here is to take a look at the life cycle of a machine. And this could be for an OEM or a replicating machine builder, a serial builder in this case. The first stage, as ever, you have a concept, an idea of a new machine. You then move through to the design of this machine, looking at all the different tools and product selections which are available and that you can utilize. And then you look at implementing these products, selecting the right ones, doing the build and the assembly, finally the commissioning of the machine, and then you start to put it into the production of the end user of the machine. And finally, when it gets to the end of the product cycle, you then enter the sort of recycling and actually scrapping of said machine. And the reality is this is the typical life cycle of any machine, and digitalization can be put through every single part of this life cycle. Everything from the AI-based tools for the sizing and selection to the commissioning and programming of these devices. But for the purposes of today, I really want to be focusing on the operate, maintain, and the optimize, and about how we can look at the improvements of OEE and other sort of general topics utilizing AI-based tools. So the best way to start this is to take a look at a typical example of where condition-based monitoring, preventative, predictive maintenance can be put in place. So we'll create a graph. On the first axis, we'll have the asset health. And because pneumatics is where Festo are well known for, I'll use a pneumatic cylinder for this example. And then on the bottom axis, we've got time. Okay, a very simple graph. And as everyone will know, this is a very, very common picture. That length of time depends on the application. We don't know how long that will take as the asset health slowly, basically degrades over time. And at some point, we'll have an incident. We don't know what that incident is, but let's take a pneumatic cylinder. It's leaking on the front nose cap. It's got a defined leak rate. It may be the leak rate exceeds a permissible value and the cylinder stops working within sort of functionality. Now, a typical process to detect on many sort of end users when they're looking at their machines and their asset healths is they'll perform what they might call preventative maintenance. So this here, as I bring it up, is a fixed schedule. Maybe every month, every 2 months, they would take a look at the machine and they would perform maintenance on a fixed time period to a fixed schedule with sort of a sort of standard sort of process. And it may be that the preventative maintenance is before an incident can even be detected, or it can even be scheduled afterwards, which can cause unplanned downtime. But the reality is the product starts to have degradation at a very early stage, but you can't really notice it at this point. And the asset health, as that decreases, so does the subsequent performance. What we can do is we can provide condition-based maintenance. And this is in sort of dashboards, etc., where you look at the data. This may be looking, let's take a pneumatic cylinder, at the air consumption of a complete line. You can start to detect it at that early point, though sometimes you might not meet it before the incident occurs. We can also take a look at what we might call, if I can read it here, preventing the failure, or potential failures come first or obvious by experienced colleagues. And what this means is whenever you're performing preventative maintenance, the quality of detecting an asset health is actually dependent on the skill and the knowledge of the person performing it. If you have an apprentice to a very, very experienced technician, the time frame at the point at which they would be able to detect that failure can completely vary in terms of quite a substantial timeline. And finally, we have the point at which predictive maintenance can actually start to detect the fault. Okay? And during this time when the degradation starts and when we can actually detect it with predictive maintenance, this is where we start to find the impact on OEE and the performance of the machine. This will even start to impact the cycle rate, the time. Let's take a pneumatic cylinder. If it's leaking, its positioning time from point A to point B starts to get longer and longer and longer, impacting the output of said machine. Okay? So all of this is impacting the overall equipment effectiveness. So if we take a look at this, what are the actual benefits of predictive maintenance? We can talk about it, but what does it actually achieve? Well, the reality is the main ones are shorter mean time to repair. If you can detect the product that's going to fail, you can already be purchasing that product for any spares. Decrease inventory costs. If you look at a large end user, they quite often hold a huge array of stock. With this type of tool, they can be buying the stocks they need and have it on site beforehand. We can also be increasing the energy consumption. Let's take a motor. It's not using the same amount of current to perform the positioning task, but also with pneumatics, we're using less compressed air. And with this, there's less unplanned downtime because we don't have these incidents occurring. So, when we start to take a look at it, when we start to monitor, optimize your machines with AI, these are the type of results that we can achieve. Typically, around a 50% reduction through more efficient processes with digital maintenance. And I've actually missed one, funnily enough. Around an increase of 10% on the overall equipment effectiveness, and around about a 25% increase in unplanned downtime. And these are the typical sort of results that we see. And it's not that these are just random facts and figures. These are actually results that we've gained through the whole entire process. And the reality is it's all good talking about it, but how do you actually achieve it? And this is where there's been a number of different AI tools developed by Festo in recent years, which can start to provide this predictive maintenance. And the first one that we've developed to start to achieve this is what we call motion insights for pneumatics. And what it does is it provides a continuous monitoring of specific cylinders. Now, there's no additional equipment required. Like any pneumatic system, you have a valve, a cylinder, and maybe a couple of proximity sensors. And what the system actually does is it takes a look at all the data in the cylinder moving from A to B and backwards when you send the output to the valve and utilizes the standard function block. And with this function block, it can be taken into environments like Siemens MindSphere, for instance. So there's no enhanced data that you need to do. The actual algorithm behind it does all of the analysis and will start to flag when failures are potentially occurring, looking at the performance of each individual cylinder. We have dashboards available for it, but you can actually parameterize it. When you change a cylinder, it will actually perform a calibration cycle. So as an OEM or a serial machine builder, you can perform the calibration and it'll provide a complete data set. So when it's at the end user, you can have all that data available. What's really nice about the tool as well is it doesn't need to just be used on Festo pneumatic components. You could have a cylinder by a Japanese manufacturer, a valve from a British manufacturer, proximity sensors from an Italian manufacturer. It's all about the I/O and the function block and all the data and the algorithm behind it actually providing condition-based monitoring. It's based on a license model as well. So you purchase the license for each individual cylinders. So normally the conversation is, let's focus on the cylinders which could have the biggest impact to you. There's also tools for electrics with AI as well, which works on a very, very similar process. The nice thing is with any sort of servo motor and controller, you have a combination of devices which are also normally connected to a tooth belt or a ball screw mechanical axis as well. And what it does, again, is it looks at the data in that standard calibration cycle. Again, a very, very similar license-based model, which can go into tools like Factory Talk or MindSphere. So all the data is available in the cloud. It performs the calibration, but it can start to detect where that failure is occurring. It can start to take a look at the following errors and tracking exactly where that following error is. Is that following error on a servo motor due to mechanical wear? additional torque on the slide, but also monitoring the current consumption as well against that motion profile. So all of this data is coming back, but rather than data for the sake of data, it starts to point to where the challenge is and provide data coming back to the user. And that could be to the OEM or to the end user in this case. Again, both of these apps that we've actually created have actually won the Automation App of the Year awards, because these are going into standard manufacturing environments and providing tangible data coming out. Now, I've spoken about 2 quick AI-based tools there, but they're not the only ones. We've also been creating actual AI-based software for more enhanced applications. So what you'll see here on the left-hand side is those 2 tools, the pneumatics insight and the electrical insight. But on the right-hand side, we're also doing a lot of tools for processes. So these tools are also being enabled for the air preparation. You may have seen that there will be air preps with flow sensors, pressure sensors, data monitoring. Well, it's not just sending data out what your air consumption is, it's actually monitoring it and holding the pressure, and doing bespoke software for weld guns as well, looking at the quality of the weld. So then they can be an off-the-shelf product, but also slightly more bespoke as well, getting all that data out. Keeping a close eye on the time so I don't overrun. But how does this all start to pull together with the end user? And basically, there's also a tool called Smartenance, as you would probably have guessed. Festo have combined the word smart and maintenance and created their own word of Smartenance. But basically, this is a single tool in which all of the data for any sort of end user with the shop floor is all combined into one single platform. With this one system, can be all for the maintenance and for the incident management, but it also creates all the PDFs, the data, the videos, and everything else into a single platform. So no more paperwork, etc., for monitoring this. And it all links into the cloud as well. So you can probably guess exactly where I'm going when I've spoken about a tool for the end users, sort of maintenance, the management, and how you perform the work, and also all the AI data as well. Is we can start to use REST APIs here. And in this, we can start to get the factory level and the asset level automation components working with the maintenance engineers and the work they need to perform, so you can actually provide complete predictive and preventative maintenance. So with this here, we get the prediction from the individual asset. The assets reporting the data in that, say, pneumatic insights, looking at the calibration, the positioning times and the data, and starting to detect where that fault is. When the data has been analysed by the software, let's take Siemens MindSphere, it's taken the data, it's analysed it and started to say there's a fault on cylinder X, for instance. It then reports this data straight into the ERP system, which then links directly to that smart maintenance tool, and the component can be ordered as well. So in a complete production environment, everything can be linked together on the shop floor, that from a machine asset level, the actual quality of the asset can link directly to the users and the technicians to order the spares available, but also the tool has all the how-to documents and videos of how to perform the servicing, well in advance of any unplanned downtime. In terms of new business models, what does this really create? And for us, there's 2 particular different business models really that could be created. The first one is for the OEMs, and that could go 2 different ways. One, that the OEM sells a package which includes all this data that the end user can place directly into their own system. The data is just an API-based call, so we'll send all the data, whatever system they have, they can take it. The other solution for the OEMs and replicators is that they can actually be selling different services, that they could be taking all this data for their machines, taking them back, and offering enhanced maintenance packages and service packages to their customers. If they've created the machine and they've got the data, they then know exactly when a cylinder needs to be repaired or replaced and be offering these services to their customers. So it starts to open up different revenue opportunities for, say, OEMs and replicators, and finally, different types of servicing for the actual end users themselves. So that brings an end to my presentation, perfectly on 15 minutes. If you've got any questions, we're on stand 161. I'm happy to answer any of those. And if you want to see any of the tools in real life applications, we're happy to organise that too. But thank you very much for your time. Cheers.